The North Carolina poultry industry generates large amounts of litter, which is a mixture of the manure from the birds and the wood shavings or other bedding that's on the floor of the houses. This contains large amounts of nutrients, primarily nitrogen and phosphorus, but also several other nutrients, and these are used to grow grass, corn, cotton, or other crops in the region. When the litter is cleaned out of a house, it's sent to a laboratory for waste analysis, and the composition of the litter as well as the crop system helps determine the appropriate application rate.
Based on the nutrient content of the litter, the target application rate is determined. Then a poultry litter spreader is used to apply the material. But how do we know that our litter spreader is applying the correct amount of litter? If we apply too much litter, it can cause soil and water pollution, and if we apply too little, it can reduce crop yield. For comprehensive nutrient management, in addition to proper litter sampling and correctly interpreting the application rate, we need to calibrate our spreader to apply the right amount of litter. This video demonstrates how to calibrate a litter spreader to achieve both uniformity of coverage and an accurate application rate. For this demonstration, we are on the farm of Mr. Ed Stevens, who grows turkeys and swine. Mr. Stevens grew up raising chickens and has been raising turkeys since 1985.
Actually, all my life I was raised with chickens, and we had layers when I was a kid, and that kind of just multiplied on into a larger operation back in the 70s. We were independent. We raised independent hatching eggs for a guy in Pennsylvania, and then we got out of that in the late 70s, and I got in the turkey business in 1985.
We asked him how litter spreading has changed over the years.
We used to, pick it up with seed forks and put it in a box spreader and put it behind a little tractor and go spread, a few 100 pounds at a time. And now we have, 18 to 24 foot spreaders on trucks or either tractors, and double spinner spreaders, and get over a lot of acres in a little bit of time.
When we go from applying a couple of tons of litter with the box spreader, as Mr. Stevens did in the 70s, to applying perhaps more than 100 tons in a day with double disc spinner spreader, we have to be more careful to apply at the correct application rate. The double disc spinner spreader like this one can apply litter at a much faster rate than the box spreader and is hence more popular. Therefore, we will focus on spreaders with double spinners. Spinner spreaders are either truck-mounted units or trailer units pulled by a tractor. The conveyor at the bottom of the hopper delivers litter to the paired spinning discs. Vanes on top of the spinner discs throw the litter behind and to the side with a typical swath width of 30 to 50 feet. We can change the application rate by changing the driving speed, chain speed of the conveyor, and the gate opening. To improve pattern uniformity, we can increase the spinner speed or reduce the distance between the hopper bottom and the spinner discs. If we have problems with our spread pattern, we can do several things that we will discuss later. Both rate and uniformity are greatly influenced by the litter properties, so the general guidelines provided by manufacturers on swath width may not apply to a particular situation. First, we need to know the swath spacing so we can decide how much overlap we need between passes to get acceptable application uniformity. Then we will use the weight area method to calculate application rate. In the weight area method, we measure the mass of litter that falls on a known area of the tarp on the ground. It's good to know the density of your litter because it will affect your swath width. Wetter litter, having higher density, will be slung farther away and produce a wider swath than drier litter. An easy way to determine your litter density is by filling up a 5-gallon bucket with litter without tapping or compacting and multiplying the weight in pounds by 1.5. You get your litter density in pounds per cubic feet. Repeat this process 3 times and use the average of the 3 values as density of the litter. For the calibration, locate an appropriate field site, preferably with minimal slope. The field should be sufficiently long to permit the spreader to speed up, maintain a steady speed in the actual test area, and slow down afterwards. A field about 200 feet long should be adequate. Having a mowed or bare surface will be desirable for setting up pans and the tarp that will be discussed later. You will need a stopwatch, 200-foot tape measure, a small weighing scale that can weigh up to 1 pound, a larger weighing scale that can weigh up to 50 pounds, a set of at least 11 uniformly sized collecting pans, a large tarp or plastic sheet, and possibly tubs or tripods to facilitate weighing. Do the calibration when the wind speed is less than 5 miles an hour and it is dry. Load the spreader approximately half full within 4 hours of the calibration runs to minimize settling and compaction. Now for the calibration. This involves 4 steps. The first step is to determine tractor speed. Next, we determine the spread pattern. In step 3, we calculate the effective swath width or swath spacing, and then finally we will determine the application rate. To measure tractor speed, measure and flag a distance of 100 to 200 feet. Without the spinners operating, make 3 passes over this course and note the average time it takes to cover it. The tractor operator should travel at about the same speed he or she would drive when applying litter. The operator should note the gear number as well as engine RPM or the speed of the machine so that the same speed can be used while determining spread pattern and application rate. You can calculate the speed using this formula. Now we will determine the spread pattern. Place collecting pans in a transect perpendicular to the tractor driving direction. You should use a minimum of 11 pans. The center pan should be between the tires, and 5 pans each will be placed to the left and to the right of the center pan to cover the total estimated application width. The distance between the center pan to the first pan on the left or right will depend on the distance between the tires as well as the width of the tires. All of the other pans should be at equal distances from one another. To improve accuracy of your spread pattern determinations, we prefer to keep the pan spacing no more than 6 feet. You can get an estimate of the total application width from the manufacturer's literature or from your own experience. It might be greater than 60 feet for heavier, lumpy material, and much lower, even less than 50 feet, for dry, powdery material. If you think that your total application width is going to be high, use more pans. Drive the spreader over the pans, making sure you don't run them over. Turn on your spinners about 30 to 35 feet before you reach the pans, and keep on applying litter 30 to 35 feet after you have crossed the pans. This is to make sure that the flow has stabilized before you reach the pans, and the pans collect all of the material that comes off the spreader as it passes. Repeat this process 3 times, going in the same direction each time. That is, if the pans are east-west, go north-south or south-north each time. This will tell you if there is a systematic difference in application rate on the right side versus the left side due to differences in the 2 spinners. The amount of litter in each pan should be weighed. This will give you an idea of the spread pattern. However, you can also visualize the spread pattern by pouring the litter from each pan into a clear container, though that is more difficult with litter because it is lumpy. If you want to see the difference in collection in each pan for the 3 runs, you can weigh the material collected after each pass. Then you can use the concept of standard deviation to see how the collection in the same pan varies from one run to another. But for producers, it is more convenient to do the weighing after at least 3 runs. Doing multiple runs helps to minimize variability due to the material not being uniform in consistency and having clods. Plot the weights in the pans to determine the pattern.
96.9.
A flat-topped pattern is ideal because it is the most uniform. An oval pattern will give you a swath spacing similar to a flat-top pattern. A pyramid-type pattern is also acceptable, but it will give you a smaller swath spacing than a flat-top or oval pattern, meaning that you will have to spend more time in the field because greater overlap is required. But a pyramid pattern is also more forgiving in the field than the oval or flat-top patterns, particularly an oval pattern, because its application rate falls off suddenly, so you have to be careful about the overlap. Whereas angled spinners will give you a pyramid pattern, flat spinners will give you a flat-top pattern. There are some problem spread patterns that may require you to make adjustments to the spreader. If you have an M pattern with low application directly behind the spreader, you need to move the point of delivery against the direction of rotation. In some machines, you do this by moving the flow divider closer to the gate. In other machines, you move the spinners farther from the gate. In the machine shown, move the spinners farther from the gate to correct an M pattern. You can angle the blades or vanes backwards if your spreader has bolted vanes. And finally, you can increase the spinner speed. Increasing the spinner speed generally improves uniformity of application. In the W pattern, you have high application rates directly behind the spreader, and then the application rate drops off rapidly and then increases again. To fix this pattern, you do just the opposite of what you do to fix the M pattern. But remember to do just one change at a time. If you cannot improve your M or W patterns and want to have high uniformity of application, consider applying half the litter going north-south and the other half going east-west. We have also seen what we would call a steeple pattern. Here you have very high application rate directly behind the machine, and the application rate then drops off rapidly on the two sides. This type of pattern is observed if the poultry litter stream is not directed onto the two spinners by an extended flow divider. Please make sure that you always have an effective flow divider. Now let's calculate the effective swath width or swath spacing. Effective swath width is the distance between the 2 points on the left and right where the application rate, or pan weight, is approximately 1/2 of the full application rate. This full rate occurs in the middle flat portion of the flat top and oval patterns. If it is a pyramid pattern, then you may have only a single pan in the middle that gives you full application rate. If you are satisfied with the uniformity of your spread pattern, your effective swath width is your swath spacing. In other words, the distance between the center lines of two adjacent passes. Note that with adjacent passes, the lower application rates on the sides will be filled up due to overlap, resulting in a more or less uniform application rate. Again, your swath spacing is affected by the density of the material. Also, angled spinners will usually give greater swath spacing than flat spinners, and higher spinner speeds will also increase swath spacing. The last step is to determine the application rate. You will need either tarps or plastic sheets. Keep the width of the tarp or plastic sheet the same as the central portion of the swath that received the full application rate for the flat top and oval patterns. However, for the pyramid pattern, since you have only one measurement with the full application rate, keep the tarp as wide as the effective swath width. The dimension of the tarp parallel to the direction of travel should be at least 10 feet. Be sure to measure the dimensions of the tarp because advertised tarp sizes are usually 6 inches short in each direction. Here we will use plastic sheets instead of tarps. Weigh the clean tarp or sheet ahead of time and make note of the weight. Lay out 3 plastic sheets parallel to one another. These sheets can be adjacent to one another or a few feet apart. Set the gate opening on the spreader to correspond to the application rate you want in the field, based on the manufacturer's guidelines or your past experience. Then drive the spreader crossing the center of the 3 plastic sheets. Make sure that the spinners start rotating about 30 to 35 feet before you reach the first plastic sheet, and continue to rotate the same distance past the other edge of the last plastic sheet. If you use a single plastic sheet or tarp, make 3 passes over the sheet, going in the same direction each time. Following each pass, the spreader should circle around to the original starting position so that all passes are driven in the same direction. Carefully roll up the plastic sheet and use a scale to measure the collection weight and subtract the weight of the clean sheet. Once you know the area of the sheet and material weight, you can use the following equation to calculate application rate in tons per acre. A pyramid pattern spreader only applies the maximum rate at the central position, so use a correction factor to adjust for this when collecting the effective swath width. Multiply the above calculated rate by 1.333 to obtain the correct rate for this pyramid pattern situation. If you have 3 sheets, you need to average the 3 application rates. Otherwise, for a single sheet, you have to divide the total application rate by the number of passes you made. If the measured rate is within 10% of the desired rate, calibration is complete. If by adjusting the driving speed within a safe range, you can achieve an application rate within 10% of the desired rate, you do not need to calibrate further. If speed change alone will not result in sufficient accuracy, adjust one machine setting at a time, gate opening or chain speed, until you come within 10% of your desired application rate. In closing, please remember to calibrate your spreader at least once a year, but it is preferable to calibrate every application season. Also, consider calibrating whenever the litter density or characteristics change. For example, with litter from different types of poultry production or with different types of bedding material.